Hello. So today we are going to study hypothesis testing, which is the second type of statistical inference. In the previous chapter, we learned estimation, and in this chapter and the following one, we are going to study hypothesis testing. So these two, estimation and hypothesis testing, are two major inference methods in statistics. So, and I already mentioned the difference in the previous chapter. The idea is that in estimation, you are guessing a parameter without any hypothesis. Like, for example, like what percentage of voters support candidate A, or what is the mean gas price in New York City, like that. So there it is just open question. You can answer with a number. But hypothesis testing is like different. So we are testing if a hypothesis or statement about a parameter is correct or not. So we have a prior statement, hypothesis, or belief about the population, and like without looking at the data. So the hypothesis is formed without data, and we are comparing the hypothesis with the data and see if the hypothesis is consistent with the observations. So examples are like this. Do more than 50% of voters support the candidate? Or is the mean gas price lower than $3 per gallon? So in these two questions, as you can see, it is a yes or no question. And also, like when you are asked yes or no question, of course there is already a statement. So in this question, I believe more than 50% support, right? And in this question, I believe the mean gas price is lower than $3. So, and then after to answer those questions, we collect data and see if the statements are consistent with data or not. So hypothesis testing is a little bit more kind of has a strange structure. It is different from estimation, and the hypothesis testing method can be kind of unnatural or sometimes counterintuitive. So I'm going to first start with a very seemingly irrelevant question. Consider a totally different situation. Suppose that I am accused of a crime, right? And I need to go to a criminal trial. I will get a trial. But but the problem is that about the criminal, there is no sufficient strong evidence. The evidence against me, or of the evidence that there is no evidence that goes against me. Neither there is no evidence that shows my innocence. So there is it's pretty much uncertain. There is no one knows the truth, but the judge has to make a verdict. What would be the final decision in this trial if there is no evidence? Am I guilty, or am I sentenced guilty, or nah? So the answer is no, because there is no evidence either way. Then I was not proven guilty, then I'm innocent. Even though there is no evidence showing my innocence, still, in the modern legal system, no evidence means innocence. So you have heard about these principles. The defendant is considered innocent until proven guilty. right? The burden of proof is on the prosecution, or like the benefit of the doubt goes to the defendant, right? So, right, maybe you are familiar with these ideas, and you have never think it's unfair, but actually, in some sense, it is unfair. Like if you just, without any context, if you just think it as yes or no question, you are favoring one of them, right? Innocence, you are favoring innocence over guilty, for even though there is no evidence. So like in that sense, it is unfair, and we are going to use. So I introduced this kind of seemingly irrelevant example because the hypothesis testing is similar, has the same structure like this. And I'll show you more examples where this kind of unfair decision rule is applied. Think about the paradigm shift. You may have heard about this paradigm. The term paradigm in like history of science is a like well-known concept. So it means that there are two, like for example, there are two competing beliefs in the old days. Geocentrism is that the sun rotates around the earth. Like in the old days, people believed the sun rotates around the earth. But we know heliocentrism is the truth. The earth rotates around the sun. But in the old ancient era, at that time there was no evidence either way. To normal people, right? Geocentrism, heliocentrism, just they are equal. If you compare them, there was no evidence. Then, but however, still people believed the geocentrism without any evidence, right? Just believed until there are enough evidence accumulated that show the geocentrism is wrong. It took a lot of time, then a lot of evidences, and many people to turn that over, right? So, and another example, your decision making itself is conservative. Like for example, when you shop or when you dine out, you may choose just the item you used before. Like you are not satisfied but not disappointed by the item, or alternatively, you may try totally a new item. Many people in this situation, many people just choose the familiar item, until you really hate it. Right? If you are not satisfied, then you may find a new item. But in many cases, if it's just so-so, then people tend to use the same item. This kind of decision making is similar. It has a similar structure as the paradigm shift and the legal trial decision, in the sense that there are two options, but one is favored even if there is no reason for that. The similar structure can be found in statistics. That's hypothesis testing. In hypothesis testing, there is a hypothesis. And hypothesis is formed before looking at the data. I just believe the mean is 0, or I just believe the percentage is greater than 50%, for example. Things like that. And then that's the existing hypothesis. And then now you have to make the decision whether you keep the hypothesis, whether you say the hypothesis is correct or wrong. You have to determine if the hypothesis is correct or wrong, but there must be some gray area. like in between them, right or wrong. But even if there is no evidence, if it looks like it's uncertain, still you will favor that hypothesis. So in that sense, I would compare the process of hypothesis testing with the paradigm shift or legal decision making or your conservative decision consumer choices, some things like that. So then if you get the idea, let me put some terminology on hypothesis testing. In statistics, or like hypothesis is a statement about an unknown parameter. Of course, so the idea is same as estimation. There is an unknown parameter, and we'd like to know about that. We'd like to understand, we'd like to guess the parameter. And here, I'm just making a statement. I think the parameter will be 0, like this. But at the same time, when you say a statement, automatically there will be a competing hypothesis, which will be true if it is wrong. So your belief is mu equals to 0. Then you are going against mu different from 0. So one of them must be true, right? Similarly, you may make a statement about some kind of probability. The probability is at least 50%. That's your belief. That means if yours is wrong, then this will be true, right? In this way, we will set up two competing hypotheses. It's like the process is like choosing between them. The null hypothesis is the hypothesis that you have before looking at the data. So it's your prior belief, belief about the parameter, and it is the favored one, and it's incumbent hypothesis. You just believe it, you just believe that the sun is rotating around you. That's your belief, and you are going to believe it until there is a super clear evidence showing that is wrong, right? So null hypothesis is the formal name for this. Null hypothesis is the incumbent hypothesis that is believed until it is proven wrong. And we are going to denote it as hypothesis 0, null. So it's out of nothing. So it's just out of nothing, just even if there is nothing, you just believe it. So it's null hypothesis. And the other side, the competing one, is the alternative hypothesis. Alternative hypothesis is the competing hypothesis, and it will be denoted as H1. Some textbooks use HA, but I will just use H1. So in this chapter, alternative hypothesis does not play much role. We will focus more on the null hypothesis. But later, we may put some structure on the alternative hypothesis, so it becomes more important in the following chapter. So in this chapter, we will primarily look at the null hypothesis only. So then, as I said, it is hypothesis testing is a yes or no question. You have to say yes or no. If there was another answering option, like I don't know, if you can choose one of 3 options, yes, say true or right or wrong or I don't know, then it would be easier. You may choose I don't know if there is no evidence, but there is no third option. Third option is not possible. You have to say either right or wrong. Like a trial, you are the judge. You have to make the decision. You have to say either innocent or guilty. There is no middle ground. You have to say sun rotates us or we are rotating around the sun. There is nothing in between them. right? So similar, that causes the weird, that brings about a weird decision structure like this. So the results of the decision from a hypothesis testing is either you say the null hypothesis is wrong, which is to reject the null hypothesis. You reject the null hypothesis if it is wrong, and then you are going to accept the alternative. And so this happens when there is enough evidence showing the null hypothesis is wrong, which is obvious. But on the other side, if you say the null hypothesis is correct, then we will call this cannot reject. Usually textbooks name it and label this as accept H0. It is also correct, but I would like to say cannot reject because it is more appropriate in the sense that even if there is no evidence, either way, still I have to accept it. So it's not accepting it, but I just could not reject it, right? So in the trial, say there is no evidence, then I have to sentence that the defendant is innocent. But it doesn't mean I'm sure that the defendant is innocent. But there is no evidence to say the defendant is guilty. So it's more like not able to reject the null hypothesis. So I think cannot reject, not rejecting the null hypothesis delivers the meaning better. And so as I said, it can be two possible cases. You cannot reject the null hypothesis if the data is strongly consistent with your hypothesis. That means certainly you are certain that the null hypothesis is correct. That's good, but at the same time, another possibility is that it's uncertain. Data look uncertain, but still you cannot reject it. It's either it's not decisive, then you cannot reject it. So it includes, this conclusion includes two possible scenarios. So when you cannot reject the null hypothesis, the conclusion is actually weak because it may imply there is no evidence. But when you reject something, this means that if you reject the null hypothesis, that means you have strong evidence. So this conclusion is a strong conclusion, right? So if you understand this, then it is clear that like what is strong and what is just kind of passive decision. And so in that sense, the null hypothesis is favored. And on the other hand, when you use the hypothesis testing method in your analysis, in your report, for example, then of course you want to make your argument strong. That means then you have to put your argument as H1. If you put your argument as the alternative hypothesis, that means your argument does not have any, is not favored. Still, if your argument wins, then your conclusion is pretty strong. Your argument is quite strongly consistent with the data. So a researcher usually wants to refute the existing theory and present a new theory, which is my argument. And then, of course, you have to put your argument as the handicapped hypothesis position, right? To make your conclusion strong. So, in this case, in our 4 examples, all can be understood in a similar manner, right? Like in hypothesis testing, the compete is between null hypothesis and alternative hypothesis. But null hypothesis is the incumbent or the favored position, and the handicapped challenger position is alternative hypothesis. And in criminal trial, defendant is innocent, like the hypothesis that the defendant innocent is favored. Because if there is no evidence, you make that decision, you choose that. And in paradigm shift theory, you believe if there is no evidence, you just believe whatever you have believed before, like geocentrism. And similarly, like decision making, if you're conservative in decision making, then you just choose what you used to choose, even though you are not much satisfied with that. So I want you to see the basic structure and then we will develop statistical methods to formulate this idea statistically. Okay, we are going to use another example in the next video. Okay, see you later. Bye.